Section 8.2 of Young and Friedman's University Physics covers the law of conservation of momentum, a very important law across the board in physics that Young and Friedman put like this. If the vector sum of all the external forces on a system nets out to zero, then the total momentum within the system must remain constant. And this is a universal law for which there are no exceptions. It is, of course, within an inertial frame of reference. What is an inertial frame of reference? Well, if you remember, an inertial frame of reference is a collection of items that are moving at constant velocity. And so they are all moving at the same velocity. They're not accelerating, they're not decelerating, they're moving at a constant velocity. That's an inertial frame of reference. Of course, you can have more than one system within the same inertial frame of reference. And we are talking about internal forces. That is, forces, the momentum within the system is what has to remain constant. The forces that are external to the system must cancel each other out. Any forces external to that collection of items has to net zero so that they're not a factor. And if that is the case, then the total internal momentum will remain constant always for all the components within the system. That is to say that the total momentum, vector P, capital P there, is going to always equal the same thing when you add up the momentum of element A plus element B plus however many other internal elements there are. So if the momentum of one of the elements increases, then the momentum of the other elements has to decrease, and so forth. Of course, P equals mv, that is to say momentum equals mass times velocity. And so another way of putting this is that the sum of the mass of element A times its velocity plus the mass of element B times its velocity and so forth will always remain the same in its total, no matter what changes in individual momentum take place within. And one of the examples that Young and Friedman give is, what if you have two astronauts who are at rest in space? So they're in an inertial frame of reference, and let's say that they start off at rest, but then they push away from each other. Then the total momentum of the one has to cancel out the total momentum of the other. That means that if the mass of one is more, then the velocity of the other one has to be less. And if the mass of the other one is less, then the velocity has to be more. But basically, the total momentum is going to be one is going to be the negative of the other, because the total momentum must remain constant within the system, and since the two astronauts are the totality of that system, they're going to simply the momentum of one is going to be the negative of the momentum of the other. So that is the law of conservation of momentum.